Today we're going to be working on remove element. So if we're given an array nums and an integer val, we want to remove all the occurrences of val inside nums array. And we want to do this in place, so we don't want to create any new data structures. And finally, we want to return the number of elements in num which are not equal to val. Essentially, by the end of this whole this whole algorithm, we want to be pointing towards the point in the list where before which we won't see any occurrence of the val integer. So the approach here, let's go through some cases. If we're given sort of this test case here, we want to remove or shift all the threes out of here. So what we would want as a final result would be 2, 2, and it wouldn't matter what's in the remaining indices. So the way we can approach this is essentially loop through the entire array and have a pointer towards to whatever index we want to replace. So if we start the pointer at 0 and we observe that this is the value we're trying to filter out, what we can do is basically keep the pointer here, but go to the next iteration in the nums array. So go to this number here, and we can swap, or not swap, but replace the 3 with the 2, and we can shift the pointer up to the next value. So when we get here, we would observe again that 2 is an element which is not equal to val. So we can simply override it, although in this case it doesn't change anything. This would basically just replace whatever thing we're pointing at. And the good thing about doing it this way is basically, suppose we had 2 3s here, and if we were pointing at the first index here, what would happen is as we're looping through the list, we would see that 3 is equal to val. So essentially we will just skip this iteration and go to the next iteration. Again, 3 is equal to val, so skip this iteration. And when we note that this index 2, the value 2 is not equal to the val 3, we would replace the replacement pointer with 2. It doesn't matter, we don't have to do anything with this 2 here, and then we would just increment the replacement pointer to the next index. So what that would do is, if we had other elements that were not 3 later on, we would simply continue on with the for loop and replace the 3 again with the 1 and update and increment the replacement pointer. And the nice thing about this again is that the replacement pointer is always going to point to the number of elements inside nums that are not val. So over here the replacement index is 2, and we have 2 integers that are not equal to 3, which is the thing we're trying to filter out. So the idea here is, again, we would want to have a replacement pointer which starts at 0. We want to loop through the list, and if the number on the current index is not equal to the value we're trying to filter out, we would then want to update whatever we're pointing at in the replacement pointer. So nums of replacement pointer, just want to make sure I spelled it right, and set it to num, and then we would just want to increment the replacement pointer to the next index. And again, we can just return the replacement pointer here because it's going to point, the index is going to point to is going to be the number of integers inside the list that are not equal to val. So this should be right. We can go ahead and run the code. Submit the solution. Okay, and there we go. So the time complexity of this would be O of n, where n is the number of integers inside nums, and the space complexity is O of 1 because we're not creating any new data structures, and we're doing this in place of the nums array. So again, the whole idea here is just to have a replacement pointer which points to an index where we want to shift or store any elements that are not equal to val. And doing it this way is probably the simplest way to do it. Another approach would be to have sort of two pointers, one pointer at the start, one pointer at the end. And anytime we basically want to increment the start pointer to point to any occurrence of val, and the end pointer point to any element which is not equal to val, and we want to basically shrink the window. And anytime we have the case where the start pointer is pointing to val and the end pointer is not pointing to val, we want to swap or essentially just replace the first, the start pointer, which is pointing to val. And we're going to work our way inwards, shrinking the window, and anytime the two indices cross, that's when we would know that we have replaced all the occurrences of val. So that would be another approach, but I think this approach is cleaner because we're not dealing with two pointers. Okay.